Hey, welcome back, everybody. We're going to get going here for our 2 o'clock session. There's still coffee in the back. If there's one thing I know about tech, we are fueled by coffee, so feel free to grab some. Next up, we have Vitaliy Shtym. Did I say it right? Okay. With Pragmatic Container Security. So welcome to the stage, Vitaliy.
Hello, everybody. Can everybody hear me well? All right, so I know the announcement was about pragmatic container security, but actually we're going to talk about my broken arm. No, I'm kidding. So I'm very light on medication today, so I can actually speak to you guys. So we're going to try to make this a little interesting. Today it's all going to be about theory, and well, let's get into it. It's hard to see you guys because of the lights, but how many of you are actually running containers today? Okay, quite a few, about half the audience. Awesome. So the goal for today is to kind of review the cybersecurity principles and how they translate to containers. And we're going to get to our first slide. So we'll start a little at a higher level. Containers, what's the purpose of containers? Is to make something work in any environment that you have, right? Breaking down the monolith is one of the words that you may hear. And when you take multiple components of single applications and then you solve the problem, it worked on my machine. You probably heard this. If you're a developer, you might have said it yourself at some point in the past. But it's trying to fix this problem where you go from one environment, whether it's test, dev, and into prod, and then something doesn't work. So that's kind of the goal of containers, to be able to eliminate the variable of the environment that inherently exists in every organization. So we're going to start with a quote. Containers provide the ability, quote from Docker, I'm sorry. Containers provide the ability to package and run applications in a loosely isolated environment. And the key word here is loosely. Every cybersecurity person, when they hear word loosely, they freak out. Because security, by default, always has been about control and limited access. And containers, by their definition, remove that kind of ritual that has been in security. Now you have different things running in different environments, cross-platform. Some things are going to be running on-prem, some things are going to be running on cloud. How do we secure it? The end of the game, the name of the game in the end is to achieve the goal of the business and not introduce any unnecessary risk. So with all this in mind, we need to understand the processes of securing containers. And as we go through these slides, we're going to cover a couple of different topics. And hopefully, we're going to touch on most of the key points. And one thing I want you to take from this talk is that the security ideas that we've all been familiar with, they don't go away because we're talking containers. And we're going to be touching on them throughout this talk. And basically, the goal is to understand that these things, the mountain that we need to climb is not as difficult and it's not as tall as it may seem initially. All right. So you may have your containers running on-prem, in cloud. You may have your own container hosts, or you're going to be running some type of service from the cloud provider. And as the environment changes, there are going to be different things that you can do versus what you can't do. And we're going to be addressing those as we go through this presentation. And the goal is to understand which components actually need more attention and when they don't. So who's familiar with vulnerability, the RunC vulnerability? And I know for some of my customers, as soon as this was launched, they've been emailing, asking what we can do, what do we need to do. Vulnerabilities, they are coming out every day, all day, for a number of different software. And that's not going to change. It's only accelerating in the recent years because they allow the attackers to have more tools in their toolkit to be able to get what they want. And that's going to be either monetary compensation from you directly by ransomware or some type of hijacking of your services, or stealing the data and then trying to use it to sell it to make more money. So nobody wants to be in the news for bad things. When you get breached, there is impact initially from financial and operational perspective, but the capital and the customer view of your company is probably #1 impact. So vulnerabilities are, as of right now, are one of the #1 things of vectors of attack for containers, as well as everything else. So if you didn't understand yet, we're going to be talking about security, but security is only one component of the full life cycle of container. The reliability, performance, costs, those are going to be different aspects that you have to keep in mind when working with containers. And most of the time when you even start talking about containers is to be able to separate yourself from the infrastructure as much as possible and to improve the delivery of the services for your business. But one thing to keep in mind, that security can be a natural part of this process without introducing too much overhead, and automation is going to be one of the name of the game to achieve that. So, shared responsibility model. This topic can apply to very different environments, but in container world, the point is that you need to understand what is that you need to focus on and what is handled by the service provider. And you see these different kind of categories: data, application, operating system, physical. So this is the kind of the infrastructure stack. And when you're on-prem, you're responsible for everything. So if you're running in your own data center, you have to provide the physical security to your infrastructure, just like you would for any server or any service in your business. The infrastructure itself needs to be secured. Then you have the virtualization layer. Right, up to this point and to OS, things are going to be the same whether it's container or not, right? You have to provide these controls regardless whether you're going to be running containers. But they change with container. So you have to keep in mind that security is not just a topic to be thought about by security department. Every single person in IT needs to keep in mind the security controls, needs to keep in mind what they're doing and how does it affect. Are they opening a door to the business by allowing something in, right? So because there's always going to be disconnect between security team and there's going to be disconnect by the rest of the business IT units. Because they don't have the full understanding or visibility to what is happening on the application layer, what is happening on the container layer, etc. And there's only so much they can gauge from just observing after the fact. So it's very important for everybody that's involved to be thinking about security and not just push it onto the security team and make it their problem. And that changes even more when you start going into the cloud. When it comes to the cloud, you lose some of the controls from your environment, and you are then just looking at the containers. And who here, the one that works with containers, who here is a security professional? They've been doing security for years and years. A couple of people, definitely less than people working with containers. And you may have background that can help you understand some of the holes that may exist, but not everybody is going to be on the same level. And it's important to understand. Hopefully, this talk is going to help a little bit in a couple of the next slides as we go into actual tasks that can be achieved through this. So as the model and the infrastructure changes, you're losing some of the control from the environment. And once you get into running a SaaS, basically just running a pure container in the environment, the only thing you can secure and the only thing that you need to focus on is going to be the container itself. And hopefully, as you move left and right in this stack, you understand where you need to focus on and which of the controls that we're going to mention in the next you need to apply. So agenda. So container environment, we kind of talked about this a little bit. The tactics is going to be one of the things we're going to talk about in the next slide. And basically, these are the 6 areas that we're going to focus on today. Container host, mentioned it a couple times already, and that will be dependent if you're running on-prem or in the cloud. There are going to be different things you can do. Network, well, inter-container traffic is going to be everywhere. So if you have multiple containers, they can talk between themselves, and you need to secure the network itself. Management stack, build pipeline, application foundation, and application itself. So these are the 6 core principles and core areas that you will have to focus on, or at least keep them in mind when thinking about container security. So we're going to start with the environment. So this is going to be an example of your kind of CI/CD pipeline in your development process. So you'll have your IDE, and you're going to be compiling code. You're going to be building your applications. And in here, it's all built on the Amazon app services. And you will have your ECR, you have your registry, and then you have where you will deploy your containers to. In this specific case, we're going to talk about AKS, Kubernetes, and they can be running on your EC2 instance, your ECS, or potentially Fargate, right? So this is kind of the life cycle of your container, is one of the examples. Your environment may be a little bit different, maybe a lot different, but there are going to be key points here that are going to be unique, the same across those environments. You're going to have your CI/CD pipeline, you're going to have your orchestration tools, and the actual environment where your containers are going to be running. So, does that make sense so far? We're on track? Awesome. So, in the next one, this is your production environment. So you have your registry. You're going to be pushing your containers to production, and they're going to be running, again, on a couple different options, whether on-prem or in the cloud. And you have to keep in mind the different communication that is happening between your environment. Like in this specific example, you will have your S3 buckets, you have your database, your Elastic Load Balancers, and your WAF firewall, right? And if you completely understand what's happening in your environment, you'll know what to expect, and you'll know what to secure. Does every container need to be able to talk to the database? That's a good question. We're going to start talking about concept of least privilege, because that's not a unique concept to containers. It's just a security control kind of idea, is that only the services that need to have access to specific things should have it, and everybody else shouldn't. And we're going to talk about permissions and other things in a couple of next slides as well. So now we're talking about the host. You have your inter-container traffic that I mentioned earlier. They're going to be talking between themselves. So you'll need to be able to either gain visibility if possible, depending what we're talking about. If we're talking about Fargate, there's not much you can do on that level. But if you're talking about, if you have your EC2 instances or ECS instances, you can actually gain visibility into that. Use native resources such as Kubernetes firewall, for example, to limit what shouldn't be talking to each other and only allow things they should. Let's see. So, and now we're going to drill deeper into those specific topics. So container, the container host itself. Important part is to use a proper base for your containers. Because again, if you're running your own host, you're managing your own host, you cannot forget about the security controls that are required there. Choose an operating system that is made for running containers. So reducing the attack surface as much as possible is going to be #1 priority. So you can harden the system. You can do things like that. NIST and SANS have really good guides on how to harden the system, but the alternative is using a operating system that's been pre-hardened. AWS provides good starting points for that, where you have container-specific operating systems, such as CoreOS, etc. You can use as your base and starting point to reduce the attack surface. Logging and monitoring tools. So whatever's happening on the host, you want to be able to gather information from that environment, so you know what is happening in real time, as well if something were to happen, to see when and how it happened. So logging is always important. SIM tools, thankfully, have become really popular in the last 5 to 10 years. And a lot of customers are leveraging that. Please do collect that information, look through it, have automation to take action when needed when something goes sideways. And again, we're going to be talking about EC2 instances and not container unique topic, patching. Again, those operating systems are going to have vulnerabilities, and unfortunately we're going to talk more about vulnerabilities today and for the next, probably forever. But vulnerabilities are there, and you need to either handle them by patching or put in controls such as IPS and network tools to be able to prevent them. So additional layers are very important on your host. Restrict IAM roles. So again, concept of least privilege. Only the people that, and only the applications and services need to have access to things. They should be able to access different components. Like I was talking about earlier, does this container need to be able to talk to a database? If no, don't let them. Don't let it. Because lateral movement from container A to B is possible, and if one container gets compromised that doesn't have database communication, but the other one that does, now you're exposing yourself to unnecessary risk. Other critical security controls can be such as application control, integrity monitoring, anti-malware. Because if you're exposing yourself to the internet, even in a perfectly air-gapped environment, there's always going to be a risk of malware or other threats that are going to be on the network. And if we're talking about cloud, well, there may be things that we don't even know yet that may be potential vectors. But again, even in the perfect world, if you had a 100% air-gapped environment, there's always a risk. But if you have something that is connected to the internet, that risk's always higher. When you have open ports, when you have vulnerabilities that are existing, or even the ones that we don't know about yet, unfortunately, the security world is not perfect. There are going to be vulnerabilities that nobody's aware of. And you don't want to be compromising your security by ignoring some of those natural and historical tools that are in place that can help you protect your network. Application control is powerful because it can lock down your host to where nothing can change. Integrity monitoring helps you identify changes as they happen, or if they did happen, to look back what exactly happened. Did permissions on the account change? New accounts get created? Is the server listening on a new port? That's very important information. And anti-malware, as I mentioned earlier, it's not going to go away anywhere. You have simple things even like coin mining and crypto mining that is just a nuisance almost, but it opens doors for other more serious threats. So things like that need to be handled. And we're going to go into things like ECS and Fargate. And we're going to go bottom to top in here because we're going from EC2 and then to ECS. So ECS, again, it's something that's provided by Amazon, but you are responsible for it. The AMIs that you're going to be running, you have to put the same controls as you would be running on your EC2 instances. Be able to protect them properly requires those same tools. Same ideas that we were talking about in the earlier slide. And if you don't want to use the provided AMIs, like I mentioned earlier, harden your operating systems, reduce the attack surface as much as possible. And Fargate. When it comes to Fargate, there is no host to worry about for you anymore, but you still have to keep in mind the concept of least privileges and just controlling the access to that. Once we're talking about the actual container itself, it's going to be a little different, obviously. The network. So VPC is going to be your primary focus. Flow logging to be able to see what's happening. You're probably starting to hear the same things over and over as we go from these different areas. And like I mentioned earlier, the security controls, security concepts, they don't fall apart or change significantly because they're all conceptual. As you move through these different environments, you have to keep the same things in mind. And those who have been working with security, they kind of see this very easily because permissions, they're going to be the same, whether for your personal Google account or your organization's Amazon account. Security groups and tasks for instances. Again, reducing the network footprint. Encrypting data in transit. That's also a very common thing to do because you need to be able to protect it at every possible stage of the way to get the optimal security. And again, all of these are recommendations. They may not fit in your specific environment, but keeping them in mind as you're building your infrastructure and running your production is going to help you check some of those vectors of attack off, and that reduces your attack surface. So even not doing, you don't have to do all of these things that we're talking about, but even doing half of them is going to be a substantial step to reducing the risks that's going to be involved in your environment. Oop, too far. So on the EC2 and ECS that I was mentioning earlier, you want to look at the network as well. Intrusion prevention system is going to be something you can do on a host level or potentially even as an appliance that you'll route traffic to your instances to protect them. Doing it on a host level allows you to scale easily without having to complicate your network infrastructure, but it will be able to protect your host and potentially your containers from remote attacks. Logging into container traffic, I believe I mentioned this in one of the earlier slides, but containers are going to be talking between each other, and that you want to be able to get the visibility of what's happening inside your host and between the containers themselves, because that's very, very powerful and very risk-inducing area of containers. AWS WAF. So again, it will help you against layer 7 attacks, and it's a native tool in AWS. It's there for you. Use it if you can. It will help you protect your applications from very intricate attacks. And you can have rules imported from third party that will help you secure the environment, leverage that metadata, that information, that expertise. You don't have to do this on your own. There are going to be there's a lot of resources already available to help you and to assist with securing and using WAF for your environment. Amazon GuardDuty is also a powerful tool. You can automate a lot of things with GuardDuty. Do not let these different tools kind of seem like it's too much overhead to actually apply them and use them, but definitely at least consider using things that Amazon already has in your toolkit that's available for you to be able to protect your environment. So we've talked about a couple of different things here, and all it comes down to is that you're going to have layers of security. There's never going to be a silver bullet for anything when it comes to security. There are going to be different ways to breach an environment and attack an environment. So the more tools you have in different layers, or the more layers you have covered, the better off you are overall. Because if you don't have a security control in one of the layers, you're relying on the next layer to catch it. But the attacks can have multiple stages, and they can have very different processes how they actually attack your environment. And it's possible they'll be able to let's say, bypass 3 of them. Maybe they are not using a vulnerability, they're using something else, or they're using a 0-day that nobody knows about. So the IPS rules may not be able to pick it up. But let's say anti-malware will be able to pick it up. Maybe anti-malware wasn't able to pick it up, but you were able to detect it on the network because the container A was trying to attack container B, or you saw there is a new communication to the database from a container that shouldn't be talking to the database. All of that together builds a very secure footprint and a secure environment. And the only way to be able to provide proper security is by layers. And unfortunately, there is no other way, at least right now, to eliminate the risk to the degree that we all want to without having multiple tools and multiple controls in different layers. Sorry, I got a little bit on a tangent here from the ECR. And again, same concept, right? Permissions. At every stage of your development and production lifecycle, permissions are going to be very high importance. You have to keep the concept of least privilege in mind every time. The roles should be very narrowed down. You never want to give full admin to anybody if they don't need it. And the only services that need to talk to other servers should have that capability. All images in your registry should be scanned. Who here uses public repo or public images and public software in the containers? Right. So who here heard about crypto mining and other malware already in public containers? Hopefully you have. But so you can download what may be completely safe, which seems to be completely safe and unmodified software, but it potentially can have vulnerabilities or malware built into it. So you have to keep those things in mind and take the protection tools that are available at multiple stages. That's why you want to scan the registry for potentially vulnerabilities in malware. Maybe somebody left some API keys or secrets in the code. You want to be able to pick those up as well. Don't leave anything sensitive laying around, pretty much. Again, systems, not people, should access the registry. So your pipeline should be fully automated. So whatever you may be using, Jenkins or other automation tools, orchestration tools, there is no reason for a person to be able to do it by hand. It should be fully automated. Kubernetes, and I mentioned this earlier a little bit. Kubernetes has a firewall. You should be using it. At least if you want to leverage that type of control on the Kubernetes network stack, excuse me. Again, restricting access to the management interface. Permissions, we're kind of going in circles now as we're touching these different points. It's all about same concepts applying to different layers of your environment. And you might not have thought about this to this depth before, but the goal is to understand that all of these different tools that you are using today, every one of them introduces complexity and risk to your environment, because they have their autonomy that allows to gain access to the rest of the infrastructure. And it's important to keep in mind that exists, that risk is there. Follow CAS Kubernetes benchmark for security. Again, there is documentation, the best practices they need to keep in mind to best secure your environment. Let's see. EKS, like I mentioned, policies, security, and least privilege still applies here. As we go left to right or right to left in the stack, doesn't matter. Permissions are always going to be important. You need to secure the environment. Security groups, access control, and leveraging the native tools are going to be the easiest way to do it. You can always use third-party tools or doing things a different way, but native tools are made to make things easy for you. The build pipeline. So securing the code itself, and I talked about scanning containers and reducing the risks that's associated there. But permissions, again, to be able to limit the access from different tools that you have where they shouldn't. The principles are going to be the same for on-prem, running your own code, or running your own infrastructure, or if you're running it in the cloud. So build pipeline is quickly becoming a target for attackers, and you as the developers are also at risk, because if I can compromise your system, I may be able to inject malware at the earliest stages or inject vulnerabilities or open doors for myself in your code very early in the development process, and it's going to be very, very difficult to find them and detect them and remove them later on. So protecting even your own workstation is very important, because that's how things now, unfortunately, are playing out. I got a little bit ahead of myself here. And kind of the same concepts, educating about security. It's not one person's job. If there's going to be, let's say you have a team of 10 developers, one person cannot be focusing on security. Everybody has to keep that in mind, because nobody's going to be able to go through everybody's code and find improper or unsecure practices. Everybody has to keep it in mind, maybe not to the same degree, but being able to know what should and shouldn't be done is very important. Third-party code. The third-party libraries can introduce vulnerabilities and can introduce risk to your development. But if you're trying to leverage, let's say you're trying to build something on your own, make sure that there's not a better way to do it already. Don't reinvent the wheel. Choose framework that is actively maintained, and that you know that you can update your code as needed. Whenever the new vulnerability comes out, you'll be able to secure it by patching it, by updating it, by pushing a new code to your development. Because if there is something that hasn't been touched for even 3 months nowadays, most likely it has a vulnerability at some point. Image scanning. I mentioned this earlier a little bit. To scan for vulnerabilities, secrets. You can mitigate the known vulnerabilities by breaking your pipeline and then fixing them instead of finding about them in production. So this reduces the work that you have to do post-fact, because if you find out there's something wrong with the code that you currently have, it's a lot easier to fix it at this stage than it is once it's already running in production. So the security cost increases the later you find out about it. Because if you already have something that's running, it also introduces risk. And it puts you on a timetable that you have to meet to be able to fix it as soon as possible. The application, container specifications. Reduce services and tools in the container itself, right? Kind of makes sense. You want to only have things that are doing the work that you want it to do. Don't have anything extra going on. Monitor port usage in containers. We talked about this a little bit on the host level to know if the host is listening to a new port. But the same thing, you want to close down the container itself so it doesn't have any unopened doors or windows, right? And track container requests closely. So you want to monitor what your container is doing, and whenever there is separation from standard or deviation of some sort, you want to be able to identify it as quickly as possible. Application code. Code quality above else. And we've kind of talked about this a little bit already, is you want to be able to have the best code possibly can, because it reduces the risk. Virtual patching, for example, can protect the host, but if you can reduce the vulnerabilities that are in your code, you're better off already. So what's next? We've covered 6 different topics in here today, and the goal here is for you to see that the concepts of security, they don't stop once you start talking about containers. There are going to be universal concepts that translate across the whole IT domain, and things like permissions, roles, access control, vulnerabilities, they are not going away just because you've stopped using a host in your environment. If you're using infrastructure as a service now, well, part of that is being handled by your service provider, and that's great. Hopefully they're doing all that work for you. But you have to keep in mind that by running container, the same principles apply to that environment as well. And kind of the culmination of this is to make sure that the systems only work as intended. So if you have, let's say you have a container and you have an application, when you press this button, only that door opens. You don't want another door to open. Kind of that's the goal here, is only have your software, in the end, you only want your software to do what you intended to do. And most of the time, the attackers are going to try to make your code do something that it was not meant to do. And all of these tools, all of these concepts we covered today exist to prevent that happening or reduce the likelihood of that happening. All right, so these are, again, to review, the 6 topics we covered today. the host, network, management stack, build pipeline, application foundation, and application itself. So understand what you can do currently in your environment from the tools that exist, and see if you were able to identify additional risks that are associated in your specific environment. Maybe you will need to change how you do something, or put in place different controls to be able to reduce the risks that you might have identified today. Thank you. Hopefully this was helpful. Any questions? Sorry. Any questions? Yes.
So as far as for IDS and IPS placement, how do you gain visibility between the container hosts and between the containers themselves? Is the network-based IPS or is it host-based?
So, yeah, so for example, if you're running containers on your EC2 instance, you can have some type of agent-based IPS that'll be able to run on a kernel level, that you will be able to see the traffic between containers on the host itself. If you have something that's going to be sitting in front of your host, then you are missing out on the information that's happening on the host. So that's the only way to be able to see that is by running it on the host itself. Okay. Yes?
Is it recommended to install EDR agent in the containers?
On the containers, if it's possible, I'm not familiar right now of any tool that you can put specifically in a container. I'm sure there's ways to get the similar information from the container, but it will give you more visibility. So it would be helpful. It doesn't have to be specifically EDR type of tool, but any type of information you can gather is going to help you see any type of deviation from the norm, or help you do root cause analysis. Kind of the EDR, the purpose of EDR is to do root cause analysis, but if something goes sideways, you want to have the metadata of what was happening on the container or in the host to know how it happened. So you want to log information like ports being opened, users created, files created. That type of information will give you the picture of what was happening or what is happening. And it's going to be the same. The answer is going to be the same for the host or the container. It just, the specific tools may be a little bit different in those two environments. Yes?
So for vulnerability scanning, do you recommend to scan the container or the host or the AMI?
So you want to have runtime protection on the host. So like the question earlier about the network, you can have an IPS running on the host that will protect the host and potentially container. You can scan the containers pre-runtime. So you can scan your registry for malware vulnerabilities, and other things that will help to make sure that whatever you're actually pushing before it runs into production is clean. And so it's kind of both. You do it at different times. The runtime protection can protect your host and the container. And then you can also do some things before you actually deploy it to production to make sure that whatever you actually have running is good and clean and doesn't have vulnerabilities, for example. Because if you're running outdated version of, I don't know, Drupal or Apache or something like that, it's going to have vulnerabilities, and then you have to put additional tools in place. You have to do extra work to protect it. So if you can eliminate it by discovering it early, when you're still in your development stage, when you're still working on it, before it's running in production, you're saving yourself time, and time is money, so you're saving yourself some time, basically, and making it safer. Does that answer your question? Yes.
One more question. For the web application firewall, I know that the marketplace has different rules that you can purchase. Without purchasing those, what's available? Is there anything that's, open source rules or anything out of the box that can be added on?
I can't think of anything on the top of my head, but we can chat later. We can see if we can track something down.
Thanks.
All right. Anything else? All right. Thank you.